I received word that some of the folks at home were concerned that they didn't have an equal opportunity to get their tech glasses, but I'm assured we ordered the same proportion to be dropped by the Amazon drone. So if you didn't get up and hear that knock or that laser, whatever it is that they do to make sure you got it. Anyway, so as we get started here in the second half, a couple things. To further illustrate this, there's this, well, why are we further along? This seems to be an obvious issue, but it's interesting how it's not. So I've had some discussions with a senior military two-star official that said, Darryl, I think this is really quite simple. So if I've got a problem with my HVAC, let's say there's a problem with the water getting to it, I call a plumber to fix it. And if the electricity's not getting to it correctly, I call an electrician. So why isn't it, if those silly electrons are doing something that they shouldn't be doing, why am I not just calling the CIO or the IT technician? Well, General, they've never worked on it before. Your folks have never let them come anywhere near it before, right? But that's certainly negotiable, right? But that needs to be articulated. It needs to be formally arranged. And it just illustrates that this problem is not all that quite simple. Although this problem has been around a while, and before we get into our next esteemed speaker, we have just another quick little video that kind of demonstrates that this capability is really intergalactic.
Our computers. I give you 60 seconds.
Get some volume. Volume to the audio. So does anybody remember Star Trek: The Wrath of Khan?
At least we know he doesn't have Genesis.
Keep nodding as though I'm still giving orders.
Oh boy.
Let's start it. Punch up the data charts of Reliance Command Console.
Reliance Command?
Hurry.
45 seconds. The prefix code?
That's all we've got.
Try one more time real quick.
Our computers.
I give you 60 seconds, Admiral.
So essentially, Khan has cornered Captain Kirk in the Enterprise, cornered in space.
Bridge.
May not make sense. He's got 60 seconds to come up with a
At least we know he doesn't have Genesis.
Keep nodding as though I'm still giving orders. Let's start it. Punch up the data charts of Reliance Command Console.
Reliance Command?
Hurry.
45 seconds. The prefix code?
That's all we've got.
Charts up, sir.
Admiral.
We're finding it.
Admiral.
Please. Please, you gotta give us time. The bridge is smashed. The computer's inoperative.
Time is a luxury you don't have, Admiral. Admiral?
It's coming through now, Com.
Reliance prefix number is 16309.
I don't understand.
You have to learn why things work on a starship.
Each ship has its own combination code.
To prevent an enemy from doing what we're attempting. Using our console to order Reliant to lower her shield.
Assuming he hasn't changed the combination, he's quite intelligent.
15 seconds, Admiral.
Khan, how do we know you'll keep your word?
Oh, I've given you no word to keep, Admiral. In my judgment, you simply have no alternative.
I see your point. Stand by to receive our transmission. Soon, lock phasers on target and await my command. Phasers locked.
Time's up, Admiral.
Here it comes. Now, Mr. Spock.
Sir, our shields are dropping. Raise them! I can't!
Where's the override? The override! Fire! Fire! Why, Castro? They've damaged the proton control and the warp drive. We must withdraw. No! 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 Must!
All right. That's how exciting this can be. All right. Okay. But even more exciting are the topics that we've got coming up. We've got solutions and we've got policy coming up. All right. So first, from the National Institute of Standards and Technology, we have Keith Stouffer, who's been essentially the architect of a lot of the NIST documents and one that's going to be near and dear to our hearts in this realm, the NIST Special Pub 882 Rev 2. So, Keith, it's all yours.
Well, thank you, Daryl, and thank you to the FFC for the opportunity here to speak. Real quick, so I've been doing what we now call industrial control system cybersecurity for going on 15 years now. Actually, we've done everything from the in the electric sector to a lot of things in the manufacturing sector. Actually, there's a picture of me from several years ago at Hoover. A little bit skinnier back then. About 3 years ago, I started brewing my own beer. Everyone thought it was very good, so now I have 3 home brews on tap at all time. That's all she wrote. So NIST has been involved in industrial control system security for probably about 15 years now. Back in 2000, we started a group called the Process Control Security Requirements Forum. And the intent of that forum was to gather end users together and to identify the security capabilities that they would like to see in new products being developed by vendors. So it was the end user voice to the vendor as to these are the types of security capabilities we would like to see in new products. We then also were working with ISA, and we were figuring out, it's like, well, we started working on this to try to address new products that are coming out. What are we going to do about the legacy systems that are going to be around for another 10, 15, 20 years? So we went to ISA and started to form what is now the ISA 99 committee, which is the committee that's developing a lot of the industrial control system security standards that are used by private industry. We then heard from the Hill, essentially Congress, saying, NIST, you really need to do something, provide a guidance document for SCADA security. And so we started writing a document up on that. Around in 2004, 2005, we started that. And published that. The first document came out in 2006, and that was when 882, Special Publication 882, first was become public. The original title was SCADA Security because we were getting a lot of pressure, essentially from the Hill, saying we have to address SCADA security. And then we had some conversations with people on the Hill, people within NIST itself. It's like, well, I really want to call this what it is. It's industrial control system security. So luckily we got the name changed after that. We then started hearing that a lot of federal organizations that own and operate industrial control systems, many of them are in the electric sector or in the Bureau of Reclamation with their dams, saying it's like, hey, we're having our Inspector General saying that we need to meet the requirements that are specified in 853, but we're really having problems doing that in our operational systems because 853 was not designed for operational systems, it was designed for IT systems. So we started we got a whole bunch of the federal agencies together and developed what turned out to be the Industrial Control System Appendix to 853. I think it was revision 2 when it first came out. That work then turned into what is the ICS overlay now, which is in 882. So we've been doing this work for quite some time, developing both standards guidelines for the federal side as well as the private sector side as well. So our current research now at NIST is, so we have a lot of these standards and guidelines that are out there. There's a lot of people that are starting to implement them. A lot of the larger organizations are. A lot of the smaller organizations are still very concerned about how to implement these cybersecurity standards in our industrial control systems without having negative performance impacts. We want to make sure that it's not going to negatively impact the performance of our system. So what we're currently doing, and I'll get into this a little bit later, is putting together a lab at NIST where we have various different industrial control system scenarios, implement the standards as they are currently written within these various different scenarios, finding different ways to implement the standards, and then measure what the performance impact is. Then we can provide some guidance to the community on here's some ways to implement this guidance that you've had, these standards that are out there. These are the things that are easiest, we found out are easiest to do. These are the things that have the least amount of performance impact to your systems. These are the ones that we found out are the most cost effective to do that. So that is where our current research is going at NIST. Now, right now, we're concentrating on manufacturing scenarios. So we're looking at process control, collaborative robotics, and additive manufacturing. We're also starting to look at a building automation system scenario as well, because over the past year and a half or so, we've heard a lot of interest from the community, hence why we're having this workshop on building automation security. So I'm sure most people are familiar with the NIST cybersecurity framework. So I just want to put this in perspective of the NIST CSF. So what we're doing, there's three aspects to the framework core, framework implementation tiers, and the framework profile. So what we're doing is developing the framework profiles specific for manufacturing currently right now. So the test bed, as I had mentioned, what we intend to do within the test bed is to mostly measure the performance impact of various different security capabilities and technologies that are implemented to meet the current standards that are out there. We also want to research various different areas, including how you do perimeter network security, host-based security, how you do things like device authentication, which is a pretty new area, packet integrity and authentication encryption. One of the big things is how do we go about securing, or what do we need to do about non-routable protocols? Because a lot of these industrial protocols, they're as most of you know, they're not like IT type of protocols. They're very different. And then what can we do to start building robust and fault-tolerant systems? The test bed, which we started putting together about a year ago, what we wanted to make sure that it was capable of is to be able to quickly reconfigure it so that we can do various different implementations of security capabilities on that. And as I mentioned before, the research outcome will be essentially guidance to the community on how to cost effectively implement these cybersecurity standards without negatively impacting their performance. So one of the standards or guidelines that we plan on implementing within the test bed is 882. So I mentioned before, 882 is a guide to industrial control system security. It's been out since 2000 was when the very initial public draft came out. It's very heavily referenced. It's used quite extensively out in the industry, and I was just actually talking to John, and he said they use that pretty much as their textbook within the class that they teach. We're currently in revision 2 of that document right now. So what I don't want to preach to the choir. Do people know what 882 is? Have people? So some people are. So the 800 series documents at NIST are the cybersecurity series of documents. So there's an 800 series document on how to do patch management, how to set up firewalls, how to do pretty much anything cybersecurity related for IT. There's probably an 800 series document on it. 882 is interesting because it's written for several different groups of people, the IT folks and then also the operational folks. So we wanted to make sure for the IT folks that we provided a good overview of what an industrial control system is, what makes them different, unique from IT systems, so that they understand that they are different types of systems when they go to be secured. There's a risk management and assessment section within the document, how to develop and deploy an ICS-specific cybersecurity program, various different ways for architecting your industrial control system for security, applying security controls to industrial control systems, and then we also have several appendices within the document that include things like threats and vulnerabilities, like you've heard from some of the previous speakers, current activities that are going on in the industrial control system space right now. So if you're interested in learning more specifically what's going on in like the oil and gas industry, we provide some overviews of that and provide links to go to those various different activities so you can get additional information if you'd like. Listing out some of the security capabilities and tools that are helpful when you're doing security within ICS. A lot of the ones that Mike talked about are on there. And then the ICS overlay, that's I'll talk about in a little bit. So some of the major security objectives that we go through within the document, and these are just a few of them, is how you restrict logical access to your network. So things like how to set up DMZs, how to use separate authentication mechanisms for the corporate environment and the ICS environment, how you architect your system so there are multiple layers. One of the worst things you can do is have a flat network where everything is connected together. One thing that's sometimes overlooked is the physical aspect to cybersecurity. That's also very important. So how you restrict physical access to components. A lot of these systems, as you know, if you have physical access to a system, to the keyboard, essentially you have admin or root privileges. You can do anything that an authorized user can do. How you protect individual components from exploitation. You heard some of these things before where you want to deploy security patches, disable unused ports and services, track and monitor audit trails, how to implement antivirus and malware protection throughout your system, how to maintain functionality during adverse conditions. So these are how you network it for redundancy. And fortunately and unfortunately, how to deploy a security solution based on potential impact. Unfortunately, there's not a one-size-fits-all for these systems. You really need to do, it's a risk management process you have to go through, come up with, you know, the security controls that are really necessary for your particular risk in that system. So the ICS overlay, what that does is provide tailored 853 revision 4 security control baselines. So you have both, you have the low, moderate, and high impact baselines specifically tailored for industrial control systems. So that it changes the actual baseline from the baselines that are in 853 Rev 4. And it also provides supplementary guidance for when you are applying those controls to the industrial control system environment. The overlay that we have in 882 is intended to be a generalized overlay specific to all industrial control systems that may need a little tweaking if you apply it to a specific sector such as manufacturing or building automation. And as I mentioned before, the overlay is now part of 882. It's Appendix G in 882. So facility control systems. So we've had a lot of discussion over the past, well, probably year and a half, 2 years as to, so 882 specifically says industrial control systems. What is an industrial control system? And we pretty much give a definition of what industrial control systems are. And it is very much manufacturing kind of centric. So process control systems, manufacturing systems, discrete types of systems. But a lot of the guidance in 882 is also very applicable to other types of control systems. Things such as, you know, building automation systems, transportation systems, medical systems. And a lot of the information that's provided in 82 can be used for pretty much any type of control system because they have a lot of similar characteristics. We are currently finalizing 882 Revision 2. We had an initial public draft comment period last summer. In 2014, we just finished up the final public draft comment period the 9th of this month. And we are currently going through and resolving all the comments that came in for that and finalizing the document. Right now, it's scheduled to be published in May of this year. I'm hoping to push that a little bit and maybe get it out in April. But what I'm telling everyone right now is it'll be finalized in May. And if it's done in April, then that's good news. When I first started talking today, I also mentioned that there's a private sector organization, ISA 99, that's been working on industrial automation and control system cybersecurity standards since about 2002. So a lot of those standards are coming to fruition right now. They are labeled as the ISA IEC 62443 suite of standards. It's a pretty large suite of standards that includes everything from policy and procedural standards, cybersecurity standards at the system level, down to cybersecurity standards at components and for the vendors. So this is the other cybersecurity standard that we plan on implementing and testing within the cybersecurity test bed at NIST. Now they are very similar to the standards that have been developed at NIST, so like the 882 ICS overlay. So instead of having 3 baselines in 853/882, ISA IEC 62443 has 4 baselines, so they actually have one that's higher than the high baseline that we have at NIST. But they are very similar, mostly because it's the same people that worked to develop those standards. So the test bed scenarios. So NIST held a workshop in December, not December of 2014, but December of 2013, to get the community together to determine what type of scenarios that they thought we should be testing within the test bed at NIST. What are the particular issues that they are concerned about that they would like to see some research done on the test bed? And the ones that pretty much came out of that workshop were you really should have a continuous process because process control is a very large part of manufacturing industrial control systems. There really needs to be some advanced discrete types of processes, things like robotic assembly or advanced manufacturing. And you really need to have some distributed operations as well. So your SCADA types of systems, things like maybe smart transportation or smart grid. So we started figuring out what we wanted to do within the lab, started doing specifications, and the one that we are doing is process control. Everything that we have within the test bed at NIST that we're going to be working on, all the hardware and software are real industrial control system hardware and software. Some of the actual scenarios are simulated or emulated. The lab we have at NIST is probably a quarter, a tenth of 20% the size of this room, so it's relatively small. We can't have a whole chemical facility up in the lab. So the actual for our chemical scenario, the process itself is simulated, but as far as the controller is concerned, it's talking to a real chemical plant. So we have coming out of the controllers. We do A to D conversion into the actual simulator itself, and then there's D to A coming from the simulator back into the controller. So as far as the controller is concerned, it's operating real pumps and valves, and it's getting real sensor feedback. We also have a dynamic robotic assembly scenario where we have two small KUKA robots that are working together to do assembly, where we also have a safety system integrated in with that, because we've heard from the community that there really needs to be the cybersecurity of safety systems is very important as well, so that someone can't take advantage of a safety system and essentially make it do what it's supposed to do when it shouldn't be doing it. So you're feeding false information, say, to a safety system. It thinks it's in a state where it should be shutting down or doing something when actually everything's fine. So the safety system does what it thinks it should be doing, shutting the system down or whatever, when it really shouldn't be. We're also working on various different transportation scenarios. One that we're currently looking at is rail. So two aspects of rail. One is the control systems within the trains itself, so things like brake controllers and essentially communication that happens within the train. And then also the systems that control how the tracks and the routing of the trains itself go. So it's the more distributed type of system as to how the trains are routed throughout the system. We're also looking at potential automotive, so things like vehicle-to-vehicle communications, vehicle to infrastructure, infrastructure to vehicle, vendor to vehicle types of communications, so the security aspects of all that as well. So the test bed, as I mentioned, we just started putting it together well, started coming together the fall of last year. So it's still relatively new. We have some of the scenarios up and running. We have the collaborative robotic assembly scenario up and going. We have right now just a plastic 3D printer in the system. The equipment for the process control system actually is scheduled to ship today, so hopefully that will be arriving within the next few weeks as well. And we also have at NIST what's called the Virtual Cybernetic Building Test Bed. Now what this is a whole building emulator. So we have a lot of control, all the control, backnet equipment is there for the hardware and software that would be used to control things like your HVAC systems, lighting control, physical access, fire detection. And that, again, is hooked up to an actual emulator, so it's not the control system thinks it's interacting with a building. It's getting, sending out all the information that would normally getting all the information back that normally would, but the actual building itself is simulated or emulated. So we have, some test bed capabilities currently at NIST where we can start doing some cybersecurity testing around building automation systems. We just need to hear from the community as to what types of things we would be good to test, and what type of information that you would like to see from NIST in this area. And with that, that's a few minutes early, end of my presentation. So I'd be happy to take questions for the next, how long do we have?
You have a couple
10
minutes.
minutes.
I've got the first question. So going back to your previous slide, so how do we contact you to suggest what we'd like to have in?
Okay, so with this,
Send
you
it to
can
your
either,
email on the next slide,
you
or?
can either send it email to me. So the person who's actually in charge of this, his name is Steve Bushby at NIST, but it's best just to contact me here, and I will coordinate what happens with that. So as with most government places, my email is easy. It's just my first dot last name at nist.gov. Other questions? Yes.
You talked about all of the standards that we have to go through. For what we haven't talked about with RMF is accreditation and the process for that. Are we going to talk about that a little bit later? One of our biggest challenges still remains. We have a catch-22 chicken and egg problem. We either got to find a customer to sponsor us. There is no standard process that says you don't need a customer. If you have a product, here is the process we can send you through to get a certification. And
Okay.
we're kept out of the competition because of that.
Okay, so certification, that's an interesting topic. So NIST doesn't do anything, is not involved at all with certification of products and all that. But there are, I think, two different organizations that are. ISA has what's called ISA Secure, which is their certification body to certify to products that meet the ISA IEC 62443 standards, which are the industrial automation and control system cybersecurity standards, of which one of those standards is security controls for products. So ISA, so if you just do a Google on ISA Secure or ISCI, ISCI, you'll get information on that. There's
Good afternoon. I come from the physical security side of the house, and I've gone through volumes and volumes of standards, and what I haven't found or any standards or any best practices for applying these controls specifically to physical security, not as a subset of building automation or IT, but talking to the physical security practitioner. I come to the physical security side from the IT world so I can understand it. When I talk to other physical security practitioners, there's no crosswalk between these standards up here and their implementation here on the ground. And I was just wondering if there's any thought to incorporating that as a subset or a separate breakout in 82, since we do have a mission critical life safety application.
Yeah, so unfortunately, so right now, pretty much everything that's discussed for physical security is the physical security of IT components,
Right.
essentially those types of components. Now, the overall physical security standards, I've been involved or heard of various different activities that want to start up with that, but so to give you an example, several years ago, I was also on the NIST Critical Infrastructure Protection Standards Drafting Team, which was the cybersecurity standards for the bulk electric system. Ongoing discussion that was going on within NERC and had been up to that point for 10 years was we need a physical security standard, just a physical security standard for utilities, for whatever. And for 15 years, everyone kept saying, we need this, but no one would step up and want to take responsibility for it because it was just something that was deemed to be too difficult and overwhelming to do. So unfortunately, I don't know of any that exist right now, and I don't know what organization would try to do that. Maybe Mike has some more information on that.
So the Department of Homeland Security Interagency Security Committee actually publishes their various criteria. So they started with the physical security criteria. They just published now what's called Combined Information Technology for Converged Systems. So the title's draft is CVS, Converged Systems White Paper. We'll make that available to everybody. Then they've also put out 2 draft guides. One is a new draft facility security plan that says how you treat your facility as well as your physical access control systems, and the implementation of PPD 21 for physical security systems. So,
And they have a cyber component to them as well?
they're all cyber component.
Okay, great. Thank you.
Thanks, Mike.
So this one's from one of our other webcasts from Joe Bush. You mentioned setting up a test bed with BAC net devices. Are you using only BAC net? And will you be looking at the MAN non-BAC net systems and devices that are used in building control industry?
So let me preface this by I am not the building automation control person at NIST. But from what I understand, within this, the current test bed, the virtual cybernetic building test bed at NIST, it is only BACnet right now. I'll have to, but I do plan to talk to the POC that's in charge of this area to see if it would be possible to add in other protocols, LawnWorks, LawnTalk, all the other building automation protocols as well, especially if we get interest from the community, as I said, that building automation, cybersecurity is something that's important and it needs some additional cybersecurity guidance on.
So the answer is ask and they will build it, right?